In this tutorial I show you how you can easily create this parallax-style landing page with Three.js, but before we jump into the code, just a short notice that I'm using my gradient HDR in this rendering. You can find my gradient HDR freebies on Gumroad to follow along, and if you want to support me, please consider getting the full gradient HDR pack with my favorite 27 gradient HDRs. You find a link for everything in the description below. I also want to give a quick shout out to the Minneapolis Institute of Art for making the model available in the public domain, and this subscriber for suggesting to make a Three.js scene with an animated rotation on scroll. So if you have any questions, feedback or ideas for future tutorials, let me know in the comments. And now, without further ado, let's jump into the code. First, we have a div with a class headline container which allows us to position the three text elements inside of it. Therein we have the three divs for the text, namely text behind blur, and text front. So if we want to change the text, we have to change all the three text equally. Otherwise we get something like this. Besides the text, we also display the canvas from Three.js, which sits inside of the canvas container to position it later. That's already the most important stuff in the HTML, so let's jump into the CSS to position and style everything. We start off by just importing some fonts from Google, set some colors in the root elements, set the margin and padding of the HTML and body to 0 and hide the horizontal overflow, so nothing too crazy. Next we position the canvas container class absolute, centered and importantly on z-index2. Keep that in mind for the other elements later. The headline container uses flexbox to center the text elements both vertically and horizontally, and the pointer events none prevents the user from highlighting the text. Then we just position all the text via the IDs absolutely and style them to our liking. Now remember how we had the canvas at z-index2, so we position the ID text behind at z-index1, the text behind blur at z-index0, and lastly the text front at z-index3. In terms of styling, I put a blur on the furthest text behind to make it look like the text is glowing. For the text in front, we can get the outline effect by setting the text color to transparent and using the text stroke, which takes the stroke width and color as its attributes. Now let me illustrate what this looks like. We have the text outline in the front, then comes the canvas, then the text in the back, and lastly the blur text. Before we start to animate everything, just a short reminder that your support means the world to me. If you enjoy this video, you can leave a like, subscribe to my channel and turn on the notifications to stay up to date about future tutorials and live streams. You can also follow me on Instagram to find my other artwork, short tutorials and stay up to date about everything. But with that, let's move on to the exciting part of the code. Our JavaScript can be divided into two major parts. First, the parallax effect, and second, the 3D animation with Three.js. So let's start with the parallax effect. First, we store references to the three text divs and the canvas. Then we define parallax scaling 1 to control the amount of scaling of the text, parallax scaling 2 to control the scaling of the canvas, and lastly parallax scaling 3 to control the camera rotation later. Next we set our variables current scroll and target scroll. The ease variable helps us to control the smoothness of the transition between the current scroll and the target scroll later on. We also set the global variable theta1 that allows us to later animate the camera in Three.js. Now that we have defined the most important values for the moment, we can start our function updateScale. We only want to update the scale for as long as the user actually sees the elements that are being updated. So let's get some information about our biggest element on the page, meaning the canvas. We define rect as the canvas's getBounding client rect, which allows us to get some important information about the element's position in relation to the viewport. So let's get the start scroll position by defining it as the window page Y offset plus the top position of the canvas, and the end scroll position as the window page Y offset plus the bottom position of the canvas. Now we can create a condition that checks the user's scroll position in relation to the canvas. The condition checks the following. First, if the bottom position of the viewport is above the starting position of our target element, or second, if the top edge of the viewport is below the ending position of our target element. In other words, it checks if the target element is outside of the viewport. If either of the conditions is true, we are not viewing the element and thus we should exit from the function without updating the parallax effect. Well, that was the less fun part because we cannot really see the effect it has, but now we can move on to the stuff that actually makes a visual difference. For that purpose, we set the current scroll as counting up by the target scroll minus the current scroll and multiplied by the ease we set earlier. Now you might rightfully wonder what the target scroll currently is. To see that, we have to quickly look below the updateScale function and find the window at event listener scroll, which defines the target scroll as the window page Y offset, meaning the actual scroll position. So if we go back, we see that the current scroll and the target scroll both start at 0 and that they update according to the user's actual scroll position. Now, by setting the current scroll inside of the updateScale function as the target scroll minus the current scroll multiplied by the ease value, which then becomes the new current scroll value on the next run of the updateScale function, we can avoid getting this kind of jerky scaling effect if the user uses a mouse that moves in increments. I know it takes a moment to wrap one side around, but at least it doesn't take so much code to create. Next, we have to define the values by which to scale the text elements and the canvas. So let's create two new variables, giving them a minimum value of 1 to have a minimum scale of 100% and add the current scroll multiplied by the parallax scaling we set earlier in order to get something like this. Now we have all we need to finally update the scale of our different elements. We simply use the style transform to scale everything according to the values we defined earlier. However, there's still the camera rotation we wanted to update on the scroll. Therefore, we set the theta1 value plus equals the current scroll multiplied by the parallax scaling 3. Before we close the updateScale function, we add a set timeout which takes the function name and a delay value, in this case 1000 over 60, which equals 60 times per second. This mimics the request animation frame and allows us to update the scale more smoothly. However, you might want to have another look at this if you're worried about the performance of your website. With that, we can close the updateScale function and add our scroll event listener as I showed you before. Then we call the updateScale and then, well, we still have to create the entire Three.js scene. But no worries, I'm just going through the most important stuff. You can find my previous Three.js tutorials in the description below to get a better understanding of what is happening here. So let's start by quickly importing Three.js, the RGBE loader to add our gradient HDR later and the OBJ loader. Then we can already create the renderer. Here we just have to make sure that we set the canvas ID as our canvas and that we set the alpha as true so that we can see the text behind our rendering. Then we just add some boilerplate stuff. Create a new scene, add our gradient HDR, set some fog and add some light and a camera, create a material, import the 3D model and add the material to it to finally get to the update function within the Three.js part of our code. Here we simply count the theta1 up to have a continuous animation. In order to have the camera rotate around the object, we define the camera position x as a sine function which takes the theta1. The same we do for the camera position z, but this time with a cos function that takes theta1 as well. We'll multiply both by the same value to move further away from the object so that we don't get stuck inside like so. Finally, we set the camera look at 0, 0, 0. Now we just add a resize and animation function and request the animation frame. And that's it, our parallax scaling landing page with Three.js and some typography. Thank you so much if you've been watching all the way until here. If you enjoyed the video, leave a like and subscribe to my channel and turn on the notifications. Also make sure to check the code via the link in the description and consider getting my gradient HDR pack. Thank you so much for your support and I'll see you in the next one.